All right, good morning. Welcome back to pre-calculus. So we're going to keep going with partial fraction decomposition. They give us a little bit harder problem this time. So let me just give you some thoughts about this one, and we'll see if we can't work through it. Use S's. They use S's a lot in differential equations. So we have 9s squared plus 18s minus 4. I know my handwriting is the worst. This is a script S. It's cursive. I just remember talking to grown-ups when I was learning cursive. So I'm going back to the second grade mark. And the grown-ups told me, like, it's not called cursive, it's called script. Like, okay. So whatever. All the teachers call it cursive, but is it called script? Okay. So we have to factor this. Okay, this is not an irreducible quadratic or an irreducible cubic. There's an s that's common. Okay, we've divided by s cubed plus 6s squared plus 9s. So what we're going to do is we're just going to factor out the bottom. That's going to be s. Now we have s squared plus 6s plus 9. There's still some stuff on the top. Okay, and if this is a quadratic, we can factor. Okay, so this is going to be s, and then we have s plus 3 squared, like that. So this is a repeated factor. Okay, so the way we set this one up is we have a linear term, so it's s. Okay, so we have an a, capital A over s, plus, and then this is still a linear term, so it's b. Okay, and then we have an s plus 3, but it's repeated, so we need a c, and we have s plus 3 squared. Okay, so we have to get all the terms on the bottom, because what's going to happen next, right? The next step is going to be, this is going to equal some stuff. And what we're going to do on both sides of the equation is we're going to multiply by this whole bottom. So parts of this are going to cancel this part, parts of it are going to cancel this, parts of it are going to cancel this one. Okay, so we've got to get all the pieces accounted for. Okay, so don't be fooled by the repeated root. I know it looks like it's going to be a quadratic, and it is, but it's not an irreducible quadratic. We can factor it into two pieces. So it still stays like this is on the bottom. This looks like s plus 3. It's still a linear term on the bottom. It's just a squared. So the corresponding piece on the top is just a constant. Okay, so that's how we set that up. Okay, so let's go ahead and have them check this for us. So this is going to be a over s. S, there we go, plus b over, and this is just going to be s plus 3, and then plus c. You might think it's going to be a bx plus 3, but it's not. Okay, it's still a linear term on the bottom. We have s plus 3 squared. Okay, and that's how we set those up. Okay, again, this is the hardest part of this problem, is to set this up like this. What? I'm lying to you. Okay, once we get done, it's not really hard, but we're going to have an a, b, and a c we have to solve for, which is going to be a little tedious with our systems of equations here. Okay, that's what they want, and then we'll move on with our lives from there. Okay, so good luck setting up those things. Don't be misled by the repeated roots. This is still a linear term, so the top is a constant. Okay, it has to be an irreducible quadratic for us to have a cx plus d over here. Okay, so just be careful about that. That's where they're going to try to trick us up. So thank you for tuning in. I'll see you in the next video.